Okay. I could not find any of my old videos on this subject matter, so what I'd like to talk about uh, is just going over the book for section 5.3, the net change theorem. Okay, so you see this theorem, net change theorem, the integral of rate of change is the net change. Let me basically explain this in the simplest terms I can. You have a derivative in the first place. That's why you see the prime there of something. For instance, when you turn on the light, you begin to use electricity. And if you went outside and turned on all your lights and you went out by your meter, you would see the meter spinning. And the rate at which that meter is spinning is how fast you are using electricity. And it keeps spinning and you keep using electricity, and with that, over time, you're going to have a high electric bill, because from the beginning of the month to the end of the month, it's how much you pay for the electricity is the total change in that electricity. So that meter that you're watching is showing you how you're spending your electricity. So that's basically what this formula does, very mathematically, very symbolically, but it really comes down to this. Starting at some point and ending at another point, you're changing something. And whether that's you're using electricity, you're spending money, you're driving down the highway from one point to another point, if you take all of that, it's going to come up to a certain amount. For instance, if you're driving in your car and you start in Gainesville, and we'll put it at time 0, and you drive for 1 hour, we'll put a 1 right there, and you're going 60 miles an hour. That is your rate of change. So put a 60 right there, because that's how fast things are changing. That's what a derivative, things are changing. So you're going 60 miles an hour, and if you go from 0 to 1 hour, you would expect this total net change, forget these symbols for just a moment right now, you would expect that net change to equal 60 miles. And if you went from 0 to 2 hours at 60 miles an hour, then you would expect it to be 120 miles. That is your change in distance. So when you're looking at your speedometer, it doesn't tell you where you're at. It tells you how fast you're moving, your change. So imagine in front of you, you got the speedometer, and it's holding a speed. Well, again, from that speed, you can derive, or more importantly, you can use an antiderivative to figure out how far you're going to travel. If you're going 60 miles an hour and you have 4 hours to travel, how far can you go? Well, you can figure that out pretty easily. 60 miles an hour for 1 hour, 60 miles an hour for a second hour, a third hour, a fourth hour. It's going to be 240 miles total. That is the net change theorem. So let's look at some of the examples here and break it down using that same idea. And I'm only going to look at a few of them, so I'm not going to look at everything that they're doing. So hang on with me. Let's see. Okay. So let's talk about what marginal revenue is. I just want to look at the bottom of it. Don't want to show you too much. Marginal revenue is the change. Okay, it's a derivative. It's how much the next one's going to cost. Well, how much you're going to charge for the next one. So the marginal revenue is the more items you produce, the more money you are going to accumulate. It's a change. So if we look at what they're asking you to compute, before you even compute it, you should know what you're calculating. So you've made 200. You're going to make 100 more to get to 300. So between the second 100 and the third 100 items, and this is the change in revenue. So when I take that antiderivative, what I'm going to calculate is the total amount of revenue that you have changed. So again, think about this in traveling down the road. You're going 60 miles an hour. You've changed 60 miles every hour. You're accumulating distance. In this case, you're changing the amount of revenue, so you're accumulating money. So we're going to accumulate a lot of money from the 200th item we sell to the 300th. So that's going to be a total net additional revenue. That's important. Change in revenue, antiderivative, accumulation of revenue. It's always that simple. If you know what this is changing, then you know what this is accumulating. This is always accumulating whatever this is. So, now, the mechanics of it. Here is the derivative function. You take the antiderivative. It's a power function. So that's going to be 26q. You're going to have this minus 0.04q squared over 2. So that's the straight up mechanics. You see it right here. And again, you're going to plug in this value and plug in that value to the simplified version. So those are the mechanics. You've already learned those. I'm not going to go over the detail of the mechanics. If not, you need to go back to the previous section to look at that. But let's talk about, most importantly, what did we just calculate here? 1,600. That means our revenue increased. We accumulated 1,600 revenue when our production increased from the beginning amount, 200, to the end amount, 300. It's always that simple. So you can basically say it right now without knowing anything about it. I'm going to go back. It becomes very mechanical. This accumulates from the beginning to the end, whatever this is changing. So that's my accumulation. From starting value to ending value, I will accumulate this change. So let's look at another one. Okay, this one's graphical. Very similar to what I was talking about earlier, your electrical bill. Okay, so we're computing energy by integrating power. So this is how much energy you're using. At the very beginning, we're starting off at just under 400, or just under 500. What are these in megawatts? That's a measure of how much energy you're using over time. So you're using energy, you're using less energy, but you're still using energy. And then we start using more energy and more energy and more energy. And then we start using a little less energy. But all here where energy is being used, energy is being used, energy is being used. So we can find the area under this curve is basically an antiderivative. And it's going to be from the beginning to the end. So from 0, which are in what? Hours. So let's think about this. Why would we be using more energy here? Well, if this is September, it's probably fairly warm in San Francisco in September. So as the day heats up, well, first of all, more people start going to work. That's always important. So turning on the lights and everything, and the air conditioning's running all day long. We're peak hours. Then people start to go home. Things cool off. The air conditioner's not working so hard. So that's how our energy is changing, how fast we're using energy. So what does this say? From the beginning of the day to the end of the day, over a 24-hour period, we are going to accumulate the total net change in energy. So how much energy are we going to use over 24 hours? Basically, we're going to calculate this area, and we can do it making little rectangles. And again, you can make rectangles that are 3 units wide, 2 units wide, 1 unit wide. This recommends that you do them 2 units wide. So you go in and you calculate 2 unit wide rectangle. And let's see. I don't know if this will let me draw on it. Nope. That's okay. So, going down, and let's look at how they mechanically, and again, I'm not going to go into details of the mechanics because that's what we learned in previous sections. The only thing you need to learn in this section is what it means. You should already know how to do all of this. All you have to learn is the words to put behind it. That's starting at hour 0 through 24 hours later, or another way of saying that in plain simple English, over one day I'm going to accumulate this energy. So, let's take a look at it. They came up with 440 for the very first rectangle. Well, let's look at that rectangle. Here it is, 2 units wide. We're going to make a rectangle. We definitely know 400 is too small and 500 is too big. So I already know it's somewhere between 400 and 500 as a total size. And this is just giving the width, the height, not the width. The width is going to be 2, which we'll use later. See, there's the 2. So we have a height of 440. And again, there's several different ways. They're using the midpoint. So we go right to the middle. There's 500, there's 400. It's closer to 400, but not much, than 500. That's how they came up with 440. So I go to the next rectangle, starting from 2 to 4. Midpoint would be at 3. And that rectangle looks like it has a height of right up about 400. What did they put? Let's take a look. Right at 400. So that's how you make the rectangles. Again, this is old stuff. All you have to learn in this section is to know that you're starting at hour 0 in the day, the beginning of the day, and going for 24 hours later, the end of the day. So over one day, you're going to accumulate this energy. So the energy used was approximately that much. The mechanics, again, nothing new here, but the energy used, because that's the total net use. Again, there's really nothing here to learn as far as mechanics, nothing new. So, let's see if we have another. Oh, that's the next section. Sorry. Nope. No, we're still good. Okay. So this is asking you to interpret what does the interval represent. Again, I'm just going to read it. Okay, what is 1? These are units of T. What is T? T is hours. So this is 1 hour and 3 hours. So from the first through the third hour, we're going to accumulate this, which is, so again, always start with that same, it never, ever, ever changes. From the first hour to the third hour, I'm going to accumulate so much of these whenever it's changing. So A sub T is absorption rate in a patient's bloodstream of a drug. So I'm absorbing a drug. So after the first hour, so from the first hour through the third hour, this is going to tell me how much my bloodstream has absorbed total. That's it. Again, there's nothing new here to mechanic-wise. It's just learning what it means. So after the first hour through the third hour, so over this 2-hour period, starting from the first hour after I took the drug through the third hour of taking the drug, I am going to accumulate that amount of drug, and it's going to be in, what are those, micrograms? Oh, I always forget what these units represent, but I believe those are micrograms per milliliter per hour. So I'm going to accumulate so many micrograms per milliliter over that 3-hour. Again, it's this unit is being accumulated over these hours. So this is what I'm accumulating over time. Hopefully that makes this a little bit more manageable to know what I'm talking about. If not, please send me some questions.